All right. Where is okay? Where is the chat? Hmm. Okay, okay. Let's just put it here so I can see. Can you hear? Okay. So it seems like everything works fine. Everything is working fine. So just just want to send my hmm, okay. It's not basically working. So let's just try it in another way. Dun, dun, dun. I don't. Where is it? Here it is. Okay. Okay. Uh, okay. How can I open the YouTube chat in OBS? I'm not very familiar with OBS. So GPT-4 says, nah, not GPT-4, now it's GPT-5, right? So get your YouTube live chat URL, go to the YouTube live dashboard, click the pop chat and settings, copy the URL. Oh my god, there is a lot to do. Okay, add the chat in OBS, open the OBS, go to the view. Where is the view? Here is the view. Here is the view, docs, custom browser docs. Click plus button and enter a name, YouTube chat, copy paste the URL. Click apply. Method 2, display chat on the stream, or if you want viewers to see the chat on your stream. Okay, so first YouTube live dashboard, then YouTube live dashboard. Here we have it. Okay, we have a, what is it? Then click the pop. Okay, live chat. Pop up chat. Okay, then what I have to do? From the settings, copy the URL from the pop-up chat window. Copied. And now we need to, next step is to basically open OBS view. Actually, I have a two things. Okay. And here I need to basically, wait a minute. Custom browser docs. Where is it? I couldn't see that. Custom browser. It's such a pain. Oh my god. Where is that? Is there an easier way to do this? Hmm. Okay, maybe I can just open the browser here instead of, let's just put it here. I think. If anybody watching our stream, can you please comment on the chat so that I can check whether it's working or not? Really, I don't like this, this thing. Basically, I don't like this. You can see that this is basically showing what are the I think sorry for that. I think that's they call it as a task manager or something like that. So I don't like it. I pretty soon I planning to shift from right now I'm using X11, I think. I don't know. Basically, I can customize the X11 or something like that. I'm not sure about that because I'm not familiar with those stuffs yet. But there is this thing called what is it? It's the name is basically it starts somewhere and it's a good name and just basically forgot what's the name for it. It's a tailwind. Mm-mm. It's a Winland, I think. And it's a Winland or something like that. You're basically the idea is basically not switching the screen like this. Instead, every panel is open like this. Maybe I can show vs.src slash like this. So everything from your browser to VS Code, if you're using Vim, NeoMem like me, and any other stuff, everything is basically you are basically like it's not a professional. It's not like a professional desktop setup. You're basically we can call it as a Windows setup. It's Windows like thing basically. If you're using Windows OS, Windows, then Windows 11, I think now they're using Windows 12. No, is what is the last launch of Windows OS? It's what is the last version? Recent version. I think it's a Windows 11 or something like that. So they all have these professional setups like this. You see. Now I'm using Ubuntu actually. It's not yeah, I'm using Linux, but it's not like a exact Linux like people would use, because this is basically Windows in Linux. I would say something like that about Ubuntu, because it comes with everything and every set of thing from UI components, from everything is set up already, and you are using like a Windows. That's it. But you can still get a lot of advantages from using Linux. But if you want a more customizable thing, there is a lot of peoples out there in YouTube, a lot of social medias like YouTube page, uh, Twitter. But the YouTube is mostly I can see them. They are basically super duper configuration, having basically super duper configuring their setup, like from basically from everything, like from the UI, from the task manager, from the coding editor from everything. Just basically start up from the thing you're actually working on, which is editor, right? If you want, you can do that. But to be honest, it's really kind of sucks, I would say, because there are so many things you need to change like that. For that, it's kind of sucks. Yeah, it takes some time to use to it, and it's take actually fair amount of time to configure everything as the way you want. Okay, let's back to the story. What you are doing here is basically we have this. If you are watching my stream, like if you're a subscriber, sorry, if you are watching my stream regularly, you know that I'm building this, you know, DL library, machine learning library, deep learning library, whatever you call. So in Rust, okay. So I think that's a cool challenge. So I just building that. I just worked on a bit, you know, for some days. Then I basically left that and leave that just okay. I'm just basically shift to another project and focus on that. Then I come back to this and that. I'd say at this point I fairly worked on this project around somewhere between uh, something like it's like more than weeks, like as like a mostly like 10 to 15 days, I would say, something like that. It's not 10 to 15 days, it's somewhere between 7 to 10 days or something like that. So but with that, I think I can achieve fair amount of progress in it. And now it's now the there is a problem. Now I can basically can achieve fair amount of progress in that. And now it have a lot of bugs in it, and still a lot of basically things to do on this library in order to basically. Right now I'm basically focusing on two supports, one the CPU and the second one is CUDA. So you know, if you don't know CUDA what it means, it's basically for NVIDIA GPUs. So right now I'm focusing on these two. So a few days ago I'm able to get a CPU version of it. And you know, the thing about Rust is it's a weird programming language, I'd say. You're building something, and you see, it's like, okay, you are building this thing for a specific thing. I'm not sure. It could be my skill issue, right? I'm not a master of Rust. I'm not a expert in Rust, but still I can program in Rust. And when I try to figure out for the CPU version, I could be able to achieve that. Okay, I could be able to train, you know, multiply some, create some matml, and create their own data structure and the backward pass and the forward pass and the loss function, something like that. and it worked. I could basically I could be able to get a same gradient and compare it with compare it with, yeah, wait a minute, this is not where it is. So okay, see, it's someone, okay, I think, okay, so this is what I'm talking about, sample. So okay, let's zoom in. So I basically, what I did is um basically take the torch, I say, and implement those basically initialize same tensor with my one set library like a Rust, uh, and the PyTorch version of it, and implement them. And this is the exact number both of them going to have. Both of them are going to have the same number and basically the same tensor. And basically, I checked multiplication, matrix multiplication of it. Then I calculated the simple loss for it, like a mean loss, and basically call a backward on it and check the say check the loss, check the gradient for each tensor, like a tensor A. Here you can see that A and B and D mean on the loss. Okay, so these are the tensor I have, and these are the grads for it, like a grad, basically grad for A, which is a gradient for the A tensor, and this is yeah, this is the, here you can see that this is the PyTorch gradient version. Okay, the gradients of the A tensor using PyTorch, and this is the gradient of A tensor with our own framework, like this one. I need to give it some name. I have that. I have some name, but exactly I don't know. Nowadays I call this as a Rusty Grad. It's basically this library. I just take this name basically inspired by this tiny grad library. It's a Python library, and same, it's basically for training neural net, and it's built by one of the famous person on this field, called George Hodge. He's really famous, and he's a very talented person. He's absolutely talented. He's not only talented, he's an expert in this field. Not like he have his own library and own hardware and own company. He's a legend. He's absolutely very talented, and this person built that. I just inspired the name from it, and so back to the story. All right. So this is the true exact version of gradient with our Rusty Grad and the PyTorch. Both of them have, you can see here, both of them have pretty good close gradient. Like you can see that, right? This one and this one, you can see that. and this one and this one. You can see that here you have 0.0430, and here you have 0.043041. So pretty close. Some variants have some variants. It's basically because the type and how they handle the floating point, floating point thing, stuffs like that, how they basically round up to stuffs like that, how they basically round the number. So that's it. And it's cool, right? So I get that I'm able to get this, but then I decided to move the code base basically for not only for CPU but GPU as well. So and then the project gets so messy. That's where this is specific to Rust, because Rust is it's not a easy language, right? It's have very complicated set of features, and yeah, it's safe. At the same time, it's very complex, and yeah, and yeah, people justify this their this I like that language. I love this language, that's for sure, because it's so complex, and it's really cool to do something in language. Even a simple thing requires you to basically push your mind to the limits, I would say, because when I'm building CPU version of it, it's like, okay, if it is a Python or C, even a yeah, C is a very simple thing, but it's a dangerous language, I'd say. C++. Nowadays, C++ is absolutely have huge amount of improvements on the safety side. So fairly C++ is it's really fairly safe. Safe to use, say. And in C++, even in C++, it's kind of simple to build, but when I get into the Rust, it's a different story. And but still, I like it because it requires you to so hard to think about the design, and everything goes with it. It's amazing. So let's get into some work. So what do you have is, so we have right now, I'm planning to just create a tensor with it. Okay, just create a tensor. So what do you have? We have a API for this. So another thing I want to basically say is that I'm not just building this all by myself. I'm using AI as well. Basically using this one. So this is Gemini 2.0 Pro, say. So it's really good model, and it's really helpful for me to basically, okay, where do I need to, basically helpful for me to write boilerplate codes, I would say. There is so many boilerplate codes and repeatable stuffs. It's very simple, not very simple, it's complex, it's a bit complex, but it's very easy to write, and stuffs like that, like creating a new function, and calling a right set of parameter for it, and stuffs like that. for those simple things, not very simple, but for those very easy programming, it's really good at. But as long as it's get into so much files and so much thing to do, then it's not a good it's not a very good. It's not. Sometimes it's behave like very weirdly, like deleted very simple things and changed some of the stuffs, deliberately breaking some of the stuffs. I don't know why. Even some of the time it's basically writing some of the codes which is basically not useful in the context or something like that. And sometimes it take the code which is also not useful, which is very useful, which is we need to have that in the context and something like that. You know, these kind of things, as long as it stays somewhere between in easy to intermediate, it's really good. But when you cross the intermediate stuff, it's not okay. So first I need to get into this file. This is one of the main file, core file our. Okay, so what we have here, we are implementing storage for it. So this is a CPU storage. Okay, right now the design is something like this. Okay, I hope you can see this. And right now the design is very simple, something like this. Okay, so this is, and this is. Just wait a minute. So this is, okay, right now the design is something like this. Okay, what you have here, this is, let's say, you can basically How can I delete that? Why it's keep coming? Why then? Oh my god. Why it's what the why I could not do. Okay. So here I have this is the actual tensor. Okay. And this is I have something like a shit. I have some kind of a CPU backend stuff and GPU backend stuff. Like you can basically see something like this, okay? Backend and like a rockam backend stuff, okay? This is what it is. And here I have a CPU storage and a CUDA storage, the rockam storage. Okay, so in between this is wrapped around basically by this tensor handle. Okay, I hope this makes sense. Okay, so this is what exactly going in a framework. So what this is. So the backend does basically every um every operation are live in here. That what exactly it is. Every operations are living here related to uh, the respect to the backend. See, you can clearly see that. And this is every not ops but every creation API lives in